Look up at the sky on a clear day. What do you see? A bright shining disk dominating the heavens. That's our sun, the very heart of our solar system. It's the reason we exist, the source of our light, warmth, and energy. Without the sun, our planet would be a frozen, lifeless rock hurtling through space. The sun's gravity holds our solar system together, keeping everything in a cosmic dance around it. Since the dawn of humanity, the sun has been a source of fascination and reverence. Ancient civilizations worshipped the sun as a god, recognizing its life-giving power. They built monuments to track its movements, their lives intricately linked to the sun's cycles. Over centuries, our understanding of the sun has evolved from worship to scientific study. Today, we know the sun is a star, a giant ball of burning gas with nuclear fusion at its core. The sun doesn't exist in isolation. It's the parent of a large and diverse family, our solar system. 8 planets, including our own Earth, orbit the sun, each with its own unique characteristics. The sun's influence extends far beyond the orbits of even the most distant planets. Imagine the sun as a giant campfire in the vast cosmic wilderness, with planets like campers at different distances. Earth is perfectly positioned in the Goldilocks zone, where the temperature is just right for liquid water and life. Have you ever wondered where the sun came from? It all started billions of years ago in a molecular cloud. These clouds are like giant cosmic nurseries, filled with the raw materials needed to make stars. A disturbance, like a shock wave from a nearby supernova, disrupts the cloud, creating ripples and compressions. As more material clumps together, the gravity in that region increases, pulling in even more material. This process, this gravitational collapse, is the beginning of the sun's story. Our proto-sun is not alone in this cosmic dance. Smaller clumps of gas and dust are collapsing around it. These will eventually become the planets, moons, asteroids, and comets of our solar system. The proto-sun, blazing brightly at the center, is surrounded by a swirling disk of gas and dust. Within this disk, tiny particles collide and stick together, forming larger objects. The core of this young star continues to contract, getting hotter and denser, leading to nuclear fusion. With the start of nuclear fusion, our proto-sun officially becomes a star, our very own sun. The sun is about 4.6 billion years old, roughly halfway through its main sequence lifetime. For billions of years, the sun has been steadily shining, providing the energy necessary for life to evolve on our planet. The sun in its main sequence stage is a delicate balancing act between gravity and nuclear fusion. It's a dynamic, turbulent ball of plasma, with a complex magnetic field and a fiery surface that's constantly changing. Let's take a journey to explore the very heart of our star, to understand what makes it tick. The sun is a giant ball of plasma, superheated gas where atoms have been stripped of their electrons. We start our journey from the sun's visible surface, the photosphere, and descend into the sun's interior. Think of the sun's interior as a layered cake, each layer with its own unique characteristics. We'll encounter 3 main layers: the core, the radiative zone, and the convective zone. Our first stop is the sun's core, the very heart of our star, a place of unimaginable pressure and temperature. The core is where the sun's energy is generated through nuclear fusion, fusing hydrogen into helium. The pressure here is over 200 billion times the pressure at sea level on Earth, with a temperature of 15 million degrees Celsius. This energy, released in the form of high-energy photons, is what makes the sun shine. These photons have a long journey ahead before they reach the surface and escape into space. Leaving the intense heat of the core, our journey continues into the radiative zone. This region extends outwards from the core for about 70% of the sun's radius. Here, energy transport is dominated by radiation, with photons constantly being bounced around. This slow, meandering journey through the radiative zone acts like a giant energy buffer. It ensures a relatively stable energy output from the sun, crucial for life on Earth. Our journey through the sun's interior takes us to the convective zone. This region extends from the top of the radiative zone to the visible surface, the photosphere. It's like a giant bubbling cauldron of plasma, constantly churning and transporting heat outwards. This continuous cycle of rising and sinking plasma creates a churning effect, transporting heat to the surface. This convective motion is responsible for the sun's granular appearance, a dynamic, ever-changing mosaic. From our vantage point on Earth, the sun might seem like a constant, unwavering presence in the sky, but the sun is a dynamic, ever-changing ball of plasma, with a fiery temperament. The sun's magnetic field is constantly twisting, turning and flipping, creating a dynamic environment. This magnetic activity gives rise to phenomena like sunspots, solar flares and prominences. Understanding these solar events and their potential impact on Earth is crucial as we rely on technology vulnerable to space weather. One of the most noticeable features on the sun's surface are sunspots. These dark blemishes, some larger than Earth, are regions of intense magnetic activity. Sunspots appear darker because they are cooler than their surroundings. The strong magnetic fields inhibit heat flow, making sunspots cooler and darker. Sunspots are fascinating in their own right, but they're also often the precursors to even more dramatic events on the sun's solar flares. These sudden, intense bursts of energy are like giant explosions on the sun's surface, releasing as much energy as billions of atomic bombs detonating simultaneously. They are a testament to the immense power of the sun's magnetic field and its ability to unleash that power in spectacular fashion. Imagine a rubber band, twisted and stretched tighter and tighter. Eventually, the rubber band will snap, releasing all that stored energy. Solar flares occur in a similar way. The magnetic field lines near sunspots can become so twisted and stressed that they break and reconnect, releasing a tremendous amount of energy in the process. This energy is released in many forms, including light, heat, and charged particles. The light from a solar flare can be so intense that it's visible even from Earth, causing radio blackouts and disrupting communication systems. The heat, though not felt directly on Earth, can heat up the Earth's upper atmosphere, causing it to expand and increasing drag on satellites in low Earth orbit. The most significant impact of solar flares on Earth, however, comes from the charged particles they release, primarily electrons and protons. These particles, traveling at incredible speeds, can reach Earth in a matter of hours, interacting with our planet's magnetic field and atmosphere, creating beautiful auroras, but also potentially disrupting power grids and damaging satellites. While solar flares are sudden and intense bursts of energy, the sun also exhibits more gradual yet equally impressive displays of its magnetic prowess, prominences, and coronal mass ejections. These majestic events, often associated with sunspot activity, involve the ejection of vast amounts of solar material into space, creating stunning visual spectacles that can be observed from Earth with specialized telescopes. Imagine giant arcs of plasma glowing brightly against the dark backdrop of space. These are solar prominences, colossal loops of hot ionized gas held aloft by the sun's magnetic field lines. They can persist for days or even weeks, stretching for hundreds of thousands of kilometers above the sun's surface. Sometimes these prominences can become unstable and erupt outwards, releasing billions of tons of solar material into space. This is called a coronal mass ejection, or CME. CMEs are like giant bubbles of plasma, propelled outwards by the sun's magnetic field. They can travel at speeds of millions of kilometers per hour, carrying with them a significant portion of the sun's magnetic field. When a CME directed towards Earth reaches our planet, it can interact with Earth's magnetic field, causing what's known as a geomagnetic storm. These storms can trigger stunning auroral displays, but they can also disrupt radio communications, GPS systems, and even power grids. Understanding and predicting these events is crucial for mitigating their potential impact on our technology-dependent society. We often think of Earth as a self-contained world, protected by the vastness of space. But our planet doesn't exist in isolation. We're connected to the sun, our life-giving star, and its space weather. The sun's magnetic field forms the heliosphere, a bubble encompassing all the planets. Earth is bathed in the solar wind, a stream of charged particles from the sun. Imagine a gentle breeze carrying tiny, invisible particles. That's the solar wind, mostly electrons and protons, from the sun's corona. This solar wind carries the sun's magnetic field, extending its influence. Earth's magnetic field deflects the solar wind, guiding it around our planet. This magnetic field, generated deep within Earth's core, shields us from the sun's particles. But sometimes the sun unleashes solar storms, and Earth feels the impact. These storms send a surge of charged particles towards Earth. When these particles collide with Earth's magnetic field, they trigger geomagnetic storms. These storms can disrupt our technology-dependent world. One of the most beautiful manifestations of the sun's influence on Earth are the auroras, those shimmering curtains of light that dance across the night sky in high-latitude regions. Known as the Aurora Borealis in the northern hemisphere and Aurora Australis in the southern hemisphere, these celestial displays are a testament to the interconnectedness of Earth and the sun. The auroras are a beautiful reminder of the sun's influence on Earth, but not all interactions between our planet and our star are as benign. Geomagnetic storms, triggered by the arrival of solar storms, can wreak havoc on our technology, leading to communication blackouts, GPS errors, and even power outages. Our increasingly technology-dependent world is becoming more vulnerable to the sun's temperamental outbursts. Imagine a world suddenly plunged into darkness, not by a natural disaster but by a wave of charged particles from the sun. It's not science fiction, it's a very real possibility in our increasingly interconnected world. Geomagnetic storms can induce electric currents in long conductors like power lines, pipelines, and communication cables, overloading systems and causing widespread disruptions. One of the most vulnerable systems are satellites orbiting high above Earth, directly exposed to the onslaught of solar storms. The charged particles from the sun can damage sensitive electronics on satellites, disrupting communication, navigation, and weather forecasting services. In 1989, a powerful geomagnetic storm caused by a coronal mass ejection knocked out power to millions of people in Quebec, Canada, plunging the province into darkness for hours. Even our increasingly reliant on GPS technology is not immune to the sun's wrath. GPS signals, though originating from satellites, rely on precise timing signals from ground stations. Geomagnetic storms can disrupt these signals, leading to inaccurate positioning information, affecting navigation systems in cars, airplanes, and ships. Our interconnected world, though seemingly robust, is surprisingly vulnerable to the sun's capricious nature. As we become increasingly reliant on technology, understanding and mitigating the impact of space weather, particularly geomagnetic storms, is becoming more critical than ever. Scientists around the world are constantly monitoring the sun, studying its behavior, and developing forecasting models to predict and prepare for these events. It's like predicting the weather, but on a solar system scale, with the stakes incredibly high. Imagine a network of sentinels, stationed in space and on Earth, keeping a watchful eye on the sun, tracking its every move, and alerting us to any potential threats. That's essentially what we have in place today, a global network of ground-based observatories and space-based telescopes constantly monitoring the sun's activity. These observatories track sunspots, solar flares, coronal mass ejections, and other solar events, providing valuable data to space weather forecasters. Just like meteorologists use weather models to predict hurricanes and tornadoes, space weather forecasters use sophisticated computer models to predict the arrival and intensity of geomagnetic storms. These forecasts give us time to prepare, to take steps to protect our critical infrastructure. Power grid operators, for example, can use these forecasts to adjust grid loads, reroute power, and even temporarily shut down portions of the grid to prevent widespread blackouts. Satellite operators can put their spacecraft into safe modes, minimizing their exposure to the most intense radiation. Airlines can reroute flights to avoid high-latitude routes where communication disruptions are more likely. It's a constant game of cat and mouse, with scientists and engineers working tirelessly to stay one step ahead of the sun's unpredictable nature. For centuries, humans could only observe the sun from afar, studying its light with telescopes. Now we've entered a new era of solar exploration, sending sophisticated spacecraft to study the sun up close. These missions reveal the sun's secrets, revolutionizing our understanding and helping us predict space weather. Understanding the sun is crucial for our technological society and well-being. Section 2, SOHO, the Solar Watchtower. SOHO, a joint NASA and ESA project, launched in 1995, monitors the sun's atmosphere and solar wind. Positioned at the L1 Lagrange point, it provides continuous solar data. SOHO's instruments study the sun's corona, magnetic field, and solar flares. Its data improves space weather forecasts, enhancing our understanding of solar impacts on Earth. Section 3. Parker Solar Probe, touching the sun. The Parker Solar Probe dives closer to the sun than any spacecraft before it. Launched in 2018, it flies through the sun's corona to unravel its mysteries. Shielded by cutting-edge materials, it withstands over 1,000,000 degrees Celsius. A marvel of engineering, it answers fundamental questions about our star. Why is the corona hotter than the sun's surface? What drives the solar wind? These are some questions it aims to answer. Using Venus's gravity, it shrinks its orbit around the sun. Traveling at over 700,000 kilometers per h, it samples the solar wind and measures the sun's magnetic field. The data will revolutionize our understanding of the sun and its impact on the solar system. The sun, our nearest star, holds many secrets, mysteries that continue to intrigue and challenge scientists. But with each new mission, each new observation, we come closer to understanding this celestial object that plays such a vital role in our existence. The future of solar research is bright, with new missions planned, new instruments developed, and new discoveries waiting to be made. Imagine a future where we can predict space weather with the same accuracy that we predict the weather on Earth. A future where we can harness the sun's energy more efficiently, providing clean and sustainable energy for generations to come. A future where we can unlock the secrets of the sun's magnetic field, potentially paving the way for new technologies, new forms of energy generation, and even new forms of propulsion. These are just some of the possibilities that lie ahead as we continue to explore and understand the sun. From ground-based observatories to space-based telescopes, from robotic explorers to human missions, our quest to unravel the sun's secrets continues. The sun, once an object of worship, then a source of scientific curiosity, is now becoming a key to our future, a source of clean energy, a driver of technological innovation, and a constant reminder of our place in the cosmos. As we continue to study the sun, we not only learn about our nearest star, but also about ourselves, our planet, and our place in the grand tapestry of the universe. We've explored the sun's birth, its structure, its temperament, and its impact on our planet. But like all things in the cosmos, even stars have a lifespan. The sun, our constant companion, is not immune to the relentless march of time. It's comforting to know that the sun, in its current form, will continue to shine for billions of years, but eventually it too will undergo a dramatic transformation, one that will have profound consequences for our solar system. Imagine, billions of years from now, the sun beginning to swell, its outer layers expanding outwards, engulfing Mercury, Venus, and even Earth. It's a sobering thought, a reminder of the impermanence of even the most seemingly eternal objects in the universe. As the sun runs out of hydrogen fuel in its core, the delicate balance between gravity and nuclear fusion will be broken. Gravity, no longer counteracted by the outward pressure of fusion, will begin to compress the sun's core, heating it up even further. This increased heat will cause the sun's outer layers to expand dramatically, transforming it into a red giant, a star many times its current size. This red giant phase will be relatively short-lived, astronomically speaking, but it will be a time of great upheaval in the solar system. As the sun expands, its outer layers will cool, turning a deep red color. It will become so large that it will engulf the orbits of Mercury and Venus, vaporizing these planets entirely. Earth, if it survives the initial expansion, will be scorched by the intense heat, its oceans boiling away, its surface transformed into a barren wasteland. It's a bleak picture, but it's a reminder that even stars have a life cycle and our sun is no exception. The sun's eventual demise might seem distant, but understanding it is crucial. It's about our place in the cosmos and the forces shaping our existence. The sun drives our climate, sustains life, and powers our world. As we explore the sun, we learn more about ourselves and our universe. It's a reminder to cherish life and marvel at the universe. Our journey through the sun, from its fiery core to its far-reaching magnetic field, has been a journey of discovery, a testament to human curiosity and our relentless pursuit of knowledge. We've uncovered some of the sun's secrets, but many more remain hidden, waiting to be revealed by future generations of scientists and explorers. The sun, once an object of mystery and awe, is slowly but surely revealing its secrets and in turn, illuminating our place in the cosmos. Think of those early sky watchers gazing up at the sun in wonder, trying to comprehend its power and its place in the grand scheme of things. Their tools were simple, their understanding limited, but their curiosity was as boundless as the universe itself. Today we have powerful telescopes, sophisticated spacecraft, and advanced computer models, but the sense of wonder, the thirst for knowledge, remains the same. As we continue to explore the sun, let us carry with us that same sense of wonder, that same thirst for knowledge. Let us inspire future generations to look up at the sky, to ask questions, to seek answers, and to never stop exploring the wonders of the universe. The sun, our nearest star, is a constant reminder that there is still so much to learn, so much to discover, and that the journey of exploration is just beginning. So the next time you step outside on a sunny day, take a moment to appreciate the star that makes it all possible. Feel the warmth of its rays on your skin, and remember that you are witnessing a star in its prime, a celestial powerhouse that has sustained life on our planet for billions of years. And as you look up at the sun, remember that you are part of something vast and ancient, a cosmic connection that binds us to the universe and to all of creation. Keep looking up, keep asking questions, and never lose your sense of wonder. The universe is full of mysteries, and the sun is a shining example of the wonders that await those who dare to explore. Our journey through the sun, from its fiery core to its far-reaching magnetic field, has been a journey of discovery, a testament to human curiosity and our relentless pursuit of knowledge. We've uncovered some of the sun's secrets, but many more remain hidden, waiting to be revealed by future generations of scientists and explorers. The sun, once an object of mystery and awe, is slowly but surely revealing its secrets, and in turn illuminating our place in the cosmos. Think of those early sky watchers, gazing up at the sun in wonder, trying to comprehend its power and its place in the grand scheme of things. Their tools were simple, their understanding limited, but their curiosity was as boundless as the universe itself. Today we have powerful telescopes, sophisticated spacecraft, and advanced computer models, but the sense of wonder, the thirst for knowledge, remains the same. As we continue to explore the sun, let us carry with us that same sense of wonder, that same thirst for knowledge. Let us inspire future generations to look up at the sky, to ask questions, to seek answers, and to never stop exploring the wonders of the universe. The sun, our nearest star, is a constant reminder that there is still so much to learn, so much to discover, and that the journey of exploration is just beginning. So, the next time you step outside on a sunny day, take a moment to appreciate the star that makes it all possible. Feel the warmth of its rays on your skin, and remember that you are witnessing a star in its prime, a celestial powerhouse that has sustained life on our planet for billions of years. And as you look up at the sun, remember that you are part of something vast and ancient, a cosmic connection that binds us to the universe and to all of creation. Keep looking up, keep asking questions, and never lose your sense of wonder. The universe is full of mysteries and the sun is a shining